Okay, let's try and simplify this question. So they want us to simplify this without using a calculator. So the first thing that we're going to do is to reduce our angles. And how do we reduce our angle? You check in which quadrant is that angle. Because if we do a quadrant like this, we know this is 0, this is 360, I have this as 90 degrees, I have this as 180, and this as 270. So now I check where is 90. Can you see that 190 is between 180 and 270? This is in quadrant 3. Right. So in this quadrant we have what? Let us use a different. Okay, let's do it like this. Okay. So in this quadrant we have what? We have 180 plus theta. So this is in quadrant 3. 180 plus theta is in quadrant 3. So we can write the sine of 90 as sine of 180. What can we add to 180 to find 190? We can add 10 degrees. Therefore, we can also reduce the tan of what? The tan of 225. You check first, where is this 225? This is between, it's also between what? 180 and 270. Right, we can write this as the tan of 180. What can we add to 180 to get 225? So if you can just say 180, or you can say 225 minus 180. The answer that you get is the one that you should add here, which is 45 degrees. Therefore, everything now, so far so good. We can divide this and reduce that cos of 100. So for this one, I know that the cos is where the cos is between 180 and 90. But now, look at this. If I say this is 180 minus 80, that one won't help us. It won't help us because now I know that the sine, this is sine 10. And sine 10, right guys, sine 10 is not a special angle. That 10 degrees is not a special angle. Let me write it down so that you guys can see what I'm trying to do on this problem. So I know that this will change into what? This will change into this. It's in quadrant. This is in quadrant 3 and sine is negative. This will change into the sine of 10 degrees. So now this will give me a problem. I need to try by all means to eliminate the sine 10 because this is not a special angle. So now I see that this guy can help us. Ne? So in order for us to use the cos of 100 to eliminate that, we can write this as what? We can write the denominator as the cos of, this is in quadrant 2, and we said in quadrant 2 of 90 plus theta. What can we add? We can add 10. Therefore now we know that this guy will change into what? This is a cofunction. This guy will change into, sine will change into cos. But now let's check, how is cos in quadrant 2? It's negative. This will change into negative, the sine 10 degrees. So I can see that those two will cancel, right? Then now we can move to the other side, this side, and reduce this, which is a cofunction. We can minus this, right? We can minus this, or we can just work it out this side. Maybe let's say I know that this is a cofunction, and this will change into the cos of alpha, because this is in first quadrant, the cos of alpha. Then this one is in quadrant 4. It's a negative angle. Negative angle is in quadrant 4. So this is negative alpha. So we can write this thing what? As positive, the cos of alpha. So without any wasting of time, I just want to take these two and multiply them. The cos alpha times cos alpha. Then I'm going to have minus cos squared alpha. So I can write this as what? I can write this as cos squared alpha. Right. So now that I have that as cos squared alpha, I can rewrite, let us quickly rewrite our equation. We know that the sine, the top one, it will be minus the sine of 10 degrees times the tan of 45. Everything is divided by negative the sine 10 degrees minus the cos squared alpha. So the sine 10, negative sine 10 will cancel. Okay, so this will cancel. We are left with what? we are left with the tan of 45. So we are left with the tan 45. Right, we are left with the tan 45 minus the cos squared alpha. Right, so I need you guys to check if you can punch tan 45. I still remember on this on the graph that tan 45 is 1. So the tan of 45, this is 1. So we're going to have this as 1 minus the cos squared alpha. Remember the cos squared alpha, this is an identity which can be written as what? This can be written as, it can change to sine squared alpha. Then, how many marks? 6 marks. Let me indicate how are they going to mark this. First thing first, you'll get a mark for changing those into the cos squared x, a mark for reducing this into tan 45, another mark for reducing that, then a mark for writing that as negative the sign. So now so far we have 4 marks. Therefore, to write this thing as 1 minus the cos squared alpha, that's a mark. So we have 2, 2, 4, 5. Then the last mark is your CA, the correct answer. Okay, let's quickly work on number B. This is an identity, and this will be the last problem for this. Number B, this is an identity. We need to prove. What do we need to prove? The cos 2x. Remember, guys, we talked about what do you see before or after cos. Né? So if I'm given this, I know that I'm going to choose the most complicated side, which is left-hand side. So I'm going to work with left-hand side, and I know that the left-hand side is equal to the cos 2x minus 1, and everything is divided by the sine 2x. So remember, you're going to check what you have after the cos 2x. So now we have 1. Not only 1, but we have minus 1. So I'm going to write down all the identities for cos 2x. So we know that the identities for cos 2x is equal to 2, the cos squared alpha, or the cos squared x minus 1. This is also equal to 1 minus 2, the sine squared x. Therefore, the last one is the cos squared x minus the sine squared x. So we need to choose from these 3 identities. Remember, we need to use the identity that will eliminate the 1, the minus 1. So we need to choose the identity that has positive 1. So if we can go through this, we need to eliminate this. This is what we are looking to remove. So now if I can use this one won't work because this one has minus 1. But this one has positive 1. So minus 1 and positive 1, I can definitely use the second one. So this tells me that where there's cos, I can substitute that as 1. We can put that as 1 minus 2, the sine squared x. Then we still have minus 1. Right. So we still have minus 1. I'm just going to remove that. Okay. So what we're going to do now, we still have this as minus 1. Everything is divided by the sine 2x. We need to write it as 2 sine x, the cos of x. Right. Then from there, I can see that the 1 will cancel. So the 1 will cancel. I'll be left with what? With minus 2. Let's write this as negative 2, the sine squared x all over 2 sine x, the cos of x. So I can see that even the 2 cancels. The 2 cancels, but guys, can we just, before we cancel, can we write the top as negative 2 sine x, therefore we have 2 sine x, the cos x, so that the sine x and the 2 can cancel. These 2 cancel, the sine x cancel, we are left with negative. We are left with negative the tan, let's just say negative the sine x all over the cos of x, which can be written as negative the tan x. Therefore, left hand side is equal to right hand side. Okay, so on the next one, I think this one, it was an easy one. But remember, you need to check. You need to check what you have before or after the cos 2x. Right. So I'm also praying that you guys get something like this. Easy one. Eh? So on this question 8, we'll work on the general solution. Right. This one is also easy. Maybe we should just do it here, but it's fine. We'll do it on the other video. We'll cover question 8.